gamers love their frame rate. Making GPUs actually faster is pretty hard, so here we are, entering into frame generation.
Is able to provide dramatic speedups of 4x or even more.
Which is basically just predicting what an in-between frame in a game would look like. So you have a real frame and another real frame, you put one right in between them, basically doubling your frame rate. And NVIDIA introduced DLSS frame generation back in 2022, and it pretty much has accomplished just that. But you know, NVIDIA is pretty busy being the most valuable company in the world right now, and they're yapping about AI all the time.
AI, then AI, generative AI era.
Conveniently, they could not figure out a way. They just couldn't figure out a way to make DLSS frame generation work on any other graphics card out there, or any of NVIDIA's even own older graphics cards.
What is the optical flow accelerator, and why do we need it?
So AMD was basically like, let's open up this frame generation thing to everyone. Even with its pretty rocky rollout, that is how AMD FSR 3 was born. We appreciate no matter what our hardware is in our computers, we can just experience frame generation, whether or not we end up even using it or not. AMD also made FSR 3 frame generation open source, so everyone has access to the code. Almost instantly, mods were made to make FSR 3 available into pretty much any game you wanted to. And I made guides on how to mod, and those mod guides were pretty popular. However, though, these mods still had their issues, like just the way that they looked every now and then, it just didn't look quite right. And honestly, the process of modding these into games was pretty intensive. Let's keep it a buck. If you're a 30-year-old dude with 10 kids, 3 wives, 4 jobs, 2 houses, the last thing you want to do when you're going to play a game is to be fighting with the game settings rather than fighting like zombies or whatever that are actually in the game. So I get it. Like, these FSR frame generation mods really are only for turbo nerds like us. But what if there is an easy way, and a high quality way, and a convenient way to add frame generation to any game? Wait, this one can triple your frame rate too? But first, you know what's more essential than FPS? The most essential part of our tech lives is the charger. And this Nexode X charger from Ugreen is special. For example, here is the 61 watt charger from Apple. The Nexode X is about the same size while delivering 160 watts total. Plus, it has 4 ports, 2 of which are capable of 140 watts to a single device through the PD 3.1 protocol. And that can take a MacBook Pro 16 from 0 to 50% in just 27 minutes. To give an idea of the insanity that is this charger, I plugged in a MacBook, Steam Deck, phone, and headphones all into this guy at the exact same time, and it was barely breaking a sweat. So just think, when you go into a trip, this guy is all you're gonna need to bring with you. And look at this next to my big fat laptop power brick and tell me that this thing ain't amazing. I just wish my laptop charged over USB-C. Hey, so check the link in the description for Ugreen's 160 watt Nexode X charger, because it may be the last charger you ever need. All right, let's jump back into the video. Thanks to Ugreen for sponsoring it. If you want to try this tool, by the way, and it is a $7 purchase, it really doesn't cost that much for how powerful this is. How much you can do with this is insane. It's going to be in the description if you want to check it out, support the creator. I don't know him personally. I just like the tool a lot. It's super cool. Lossless Scaling. Obviously, you might think of the name and it's like lossless scaling. That does nothing to do with frame generation, but there is frame generation in it. You can even hide it if you think it's ugly or something. But this has mainly been known for its upscaling a game or upscaling any application actually in general. You can apply it to it. There's all kinds. You got AMD FSR, NVIDIA image scaling, integer, nearest neighbor, all this stuff. I don't know how anime got into scaling, upscaling in games, but I really care about the frame generation. And it amazed me. Here were my first impressions trying it. Let's try LSFG 2.1. Let's do 40 FPS. So it should frame generate up to 120, right? You know, there's some garbling. Like, I can see it. Just with my naked eye, my naked eyes, I don't feel any noticeable latency. Like, it doesn't feel any different than what it would feel like playing at 40 FPS. Like 40 FPS feels delayed anyways. I'm impressed. I mean, there's visual issues, but they're nowhere bad. I mean, we're running natively at 40 FPS going to 120 right now. And after those first impressions, I went on to play Last of Us Part 1, finished the game for like 4 hours, going from 60 FPS to 120 FPS. So if that tells you that I liked it, then I liked it, all right? And I gotta ask you this question. You might be a hater of frame generation. It's like, it's fake frames, it's terrible, and all that stuff. Genuine question. Would you rather be playing at 60 FPS or would you rather be playing at 120 FPS? Because that's what it feels like. I capture this footage at 120 FPS and I'm slowing it down so that you guys can see the differences between them, because this is just a 60 FPS video. I mean, it's just all weird stuff with YouTube. The difference between these two and their smoothness is absolutely massive. So we're in Last of Us Part 1 here, and I don't know what it is with me. Like, this has been like my testing game of choice as of lately. You can see in the top left, we are on the RX 7800 XT. Obviously a very fast card. We're on ultra settings, 1440p with no upscaling whatsoever. Getting 80 to 90 FPS, which is already pretty comfortable to most people. It's not what we're talking about today. This is what we're talking about here. So here is the Lossless Scaling app. This is a completely separate application. So it doesn't know what you want to add the frame generation to. You actually have a hotkey so that you can apply it to whatever app you're in when you're in game. All right, so the default hotkey is Control-Alt-S, and you can also set it in a different way. Like if you want to set, it gives you a timer. So like if it counts down from 5, 4, 3, 2, 1, then you go to the one that you actually want it to go. And then you can set it like that as well. That also works. You can have the X2 mode, or the ×2 mode, or the ×3 mode. Unfortunately, I'm not going to be able to really show you guys the ×3 mode that extensively. I have a 120 Hertz monitor, and this is only going to generate frames up to the refresh rate of your monitor. You can see in the top left of this, the one on the left is your frame rate before, and then the one on the right is the frame rate that you're actually seeing. This is what it is. So we're getting like 80, and you can see it's only going to 120, which is the refresh rate of my monitor. You might have a higher refresh rate monitor, you can take better advantage of this. My monitor is actually the 165 Hertz, but how all my cables and stuff work, I can only put this out at 120 Hertz. It isn't actually ideal to have a variable frame rate in the top left. It can do it. You're not really supposed to use this without a frame rate cap. What we're gonna do here is we're gonna cap our frame rate to 60 FPS. And what this allows us to do is double our frame rate from 60 to 120 Hertz. And I actually see and feel it feels better. It looks smoother. There's less artifacts and everything in that because we capped our frame rate. That'll be a very important thing that we're gonna go into later. In order for me to show you the ×3 mode, I have to go all the way down to 40 FPS. And honestly, at 40 FPS, the frame generation does not have that much data to work with, and it really doesn't look that good. The game doesn't feel as, snappy and all that stuff. So it isn't really recommended to play it like this, but you definitely can. This just allows you to breathe life into your graphics card. And there's some other advantages with using frame generation in this way. You can also bypass frame rate caps. Like certain games like Elden Ring, I know that game is capped to 60 FPS. But with a tool like Lossless Frame Generation, you can actually double that frame rate or triple that frame rate from 60 FPS to 180 FPS. Yes, you can do this in these type of games like with mods and all that type of stuff, but you don't have to mod the game with this. Or sometimes when you're emulating different games, they have a frame rate cap too. It'd be a lot harder to mod an emulated game. And also for everyone who has a higher refresh rate monitor, these frame generation can just help you achieve a higher level of smoothness in these games and utilize that stupidly high refresh rate monitor. I know, I see you all with 240 Hertz, 480 Hertz monitors, all that stuff. This can help you out a lot. What's crazy though is Lossless Scaling is doing all of this without even having access to hardly any of the game data. As you know, DLSS frame generation by NVIDIA and FSR3 frame generation by AMD are integrated directly into games. which in turn gives them all kinds of benefits with all that juicy data that's available to them. They have things like motion vectors in the game. They can see the performance and the frame timing they need to insert the frames into the game, and it also gives them the ability to layer the frame generation underneath the UI of the game. These are all major advantages that we have to work around with lossless frame generation that we're going to dig into later, but these ones that are integrated into the games like DLSS, FSR, frame generation, they have one major caveat. They have to be integrated into the game. Like, that is a huge point. Like, you got to put that work on the devs, whereas in this case, you can just kind of put it in any game that you want. So that is one of the reasons why AMD made this. So if you look on the left side of the screen, you can see AMD FMF. And that stands for AMD Fluid Motion Frames. Now, this is a frame generation technique that is integrated into the driver for your graphics card and not into the game, not into an external program or anything like that. 80 FPS or so, okay? And then we can go here and we can turn on, I like how it moves the overlay to the side. We can turn on AMD Fluid Motion Frames. And you can see in the top left that our frame rate went from 80 to like 150. Didn't exactly double. It's pretty close. You might think that's really cool. It's like, oh, we can just put frame generation in any game. And you know, if we're very careful and stuff, it's like, oh yeah, that's pretty cool. But honestly, just first off to me, like where the frames are, like the game doesn't feel significantly smoother. Like, let me just turn on and off this AMD Fluid Motion Frames. I know I'm only recording this right now at 60 FPS. But genuinely, it doesn't feel that much better, guys. I can't even really tell. And then there's also other things. Because AMD, in all of their wisdom, they could not integrate this into games. So that means if you move your mouse really fast, you can see in the top left of the screen that our frame rate, our generated frames, drops down significantly. And when I stop moving the mouse, it goes up to 180 again. If I move it around a lot, you can see when I move my mouse, they intentionally stop generating frames because AMD isn't confident that it's going to look good, which is so stupid, for one, because that's exactly when you would want more frames, is when you're moving your mouse more. You want the smoothness, the added smoothness to make the game look smooth. It's so pointless, in fact, that we're on PC playing games. But honestly, if you're using AMD Fluid Motion Frames, you should probably play on a controller, because the controller moves so much slower that your frame rate, if you look in the top left, doesn't change that much from moving your camera around, whereas a mouse makes it really jittery. The only use that I personally have found for AMD Fluid Motion Frames is basically if you're in a third-person game, kind of like this one, where you don't have to move your camera as much, for one. And then number two, if you're already at a very, very high base frame rate and you're just trying to get your FPS like way into the stratosphere, like going from 240 FPS all the way up until to 480 FPS or something like that. And the fact that this is layered on top of the game, not integrated into the game, well, AMD Fluid Motion Frames can have some issues, okay? Now, it's kind of hard to see here, but if I slow down my mouse enough that we get the frame generation, you can see if I zoom in here, that the HUD of the game is actually getting duplicated and frame generation is going on here. I can cap the frame rate to make it more obvious. It's going to be even more obvious. So you can see just moving my mouse around, the garbling is going on with the crosshair here. And this just happens with any static elements on the screen, because usually like it's hard for a game to predict what's being generated behind it. This is called occlusion. So when the UI is covering up something behind it, the game is trying to predict what that thing is behind it, and it's very, very difficult. You might think because lossless scaling is doing a very similar thing to AMD Fluid Motion Frames being layered on top of the game, that you would think that lossless scaling is bad. Come in here. The difference between lossless scaling and AMD Fluid Motion Frames is that lossless scaling is actually good. I'm gonna turn off the AMD Fluid Motion Frames and turn that off. Bye-bye. And let's go ahead and turn on lossless scaling. Doesn't look bad, and the frame rate isn't dropping dramatically when I move my mouse quickly. I know this is crazy. I don't know how they do it. It's insane, but that's exactly what lossless scaling does. And if you do look here, even though I'm moving my mouse fast and everything, the UI for the game, it disappears a little bit. Like you can see in the middle, it kind of looks a little translucent, but generally speaking though, the UI looks pretty damn good for what it is. I mean, we're frame generation, half of these frames are completely fake. Obviously I'm capturing at 60 FPS right now. Might be wondering how they do this with lossless frame generation. And it's actually because they use machine learning. I don't know why I quote machine learning, because I actually do use it. They train a model. That's basically what people are calling AI nowadays. And don't be scared of AI here, because this is genuinely good and it makes games better in this case, which isn't always the case for AI. Basically, over THS, the guy who makes it, trained a model for predicting the frames that go in between the other ones in games. Just like how NVIDIA does their DLSS frame generation technology, or how NVIDIA does DLSS upscaling, or Intel uses machine learning for XeSS, their upscaling technology as well, which make them look pretty damn good. And on that same note, AMD for being so stubborn with this shit. Like FSR is noticeably worse than DLSS and XeSS, but for some reason AMD is like, nah, we're not gonna use AI. Maybe at some point in the future they will, but AMD has been so stubborn with this that Sony has even been like, nah, we're gonna make our own AI upscaler for PlayStation. You AMD for being so freaking stubborn. Rant aside, the machine learning helps the frame generation a lot here. It knows what is UI and what is not UI, and is trying to preserve that and not letting it get garbled with the frames. I mean, it's not perfect, but it does a really good job for it basically having no access to the game data. It doesn't know what's happening inside the game. Speaking of it looking good, I made a pretty bold claim earlier that it can look better than FSR3 frame generation, even though FSR3 has access to the game data. Okay, here we are again in NVIDIA's iCat tool. Right here, you see that I have 120 FPS footage and I'm slowing it down to 30 FPS so we can see the differences here. And I just wanted to point out first, and I'm gonna hide my camera, that on the left side is the original 60 FPS, and you can see on the right side, is the lossless frame generation, and on the middle is the FSR3 frame generation. 60 FPS native looks a lot more choppy. This is native 120 FPS footage on the left side of the screen now, and you can see that these don't look that bad in comparison. Like the left side is as smooth and as responsive as it's going to get, but the ones on the right really aren't bad whatsoever. Okay, so 60 FPS is on the left, which is just native, and then in the middle is FSR3, and on the right side is lossless frame generation. And I just want to pull attention to this. I didn't mess this up or anything. This is the weirdest occurrence that I've seen. Usually FSR3 frame generation looks pretty good, but I think it's pretty obvious here that in Last of Us Part 1, this shadow looks like, what the hell is going on there? Like the right side with lossless frame generation, it looks smoother than the 60 FPS footage on the left, but then FSR3 is like, what the hell is happening? There's also like this like haloing effect almost, whereas on the right side with lossless frame generation, it's not as severe. What is happening? So it does not look very good here. I will say that usually FSR3 frame generation looks good, but it is not showing off very well in this game whatsoever. I'm gonna show off some of these issues that lossless frame generation can have. There's almost like this like smudging effect around the shadow here on the right side. That's not YouTube compression or anything like that. That's just how it looks. You see FSR3 does better with that, but the visual distractions that it has are just so bad I can't handle it. Obviously, one major advantage for FSR3 is that it's integrated into the game, right? Yeah, the UI should look good. You see that the crosshair looks exactly as it should. But on the right side, there is definitely some issues with it. You can see it kind of phases in and out at times. This can be distracting. I don't think it's really that bad though. It doesn't distract. Like I preferred to play the game with this on rather than playing at 60 FPS native. So I think that says a lot. Let's compare it to DLSS frame generation. So this is a Cyberpunk benchmark. On the left side of the screen, you can see that we're at 120 FPS, right? That is what the game should look like if it's running completely properly. I wanted to look at this here because surprisingly, lossless frame generation can do really well at times. Like, let me just rewind that on there. Do you see how garbled and weird it looks on DLSS frame generation? That's wild. That is wild, guys. Now, I'm not saying that lossless frame generation here has really, there's almost like a haloing effect going on with the bars as you're going through, because there's just so much occlusion going on, especially not having access to the game data. The lossless frame generation doesn't have as much to work with. As you can see here in the middle, we actually have DLSS frame generation going from 60 to 120 FPS. Native 120 FPS, I mean, compared to the frame generation ones, it really doesn't look that bad here in Plague Tale Requiem. I don't see even many major issues in this game. The only thing that I'm seeing here is like sort of that weird smudging effect that goes on here. So you see like where her legs are, because there's a lot of detail going on there. Instead, DLSS frame generation looks actually pretty sharp and everything. Native looks even sharper, but you can see with the frame generation techniques, you kind of see like the world is mushing together. It almost makes, honestly, it looks gross. It's like bleh. It's like everything kind of slurs together in the frames, and it can look a little bit unnatural in motion here, but overall, it's not anything that bad. And when you're playing at 120 FPS, I'm just saying, it's pretty hard to notice. You know, I notice these small things when I'm playing, but they don't really bother me that much. But the most major thing that I saw when I was playing Last of Us Part 1 was actually when I was in like this blizzard storm, right?
That's having some issues. All right, so I'm gonna turn off. So that's it off. That's it on. It doesn't look like in gameplay, it isn't really that distracting, but it doesn't distract me that much while you're actually playing the game. But it's definitely present.
Because of all these particles that were going down in the storm, all this fog effects and everything, it did struggle to use lossless frame generation. It looked weird. I thought it looked a little weird, and I turned it off, and I was like, oh, that's definitely the lossless frame generation doing all these effects. In any situation when there's a lot of movement, a lot of particles moving, anything like that, lossless frame generation, not having access to the game data, does struggle a lot more than these other frame generation techniques. But I bet you're wondering, like, what if I want to use the ×3 mode? I want to get from 40 FPS to 120 FPS. How the heck does that look? Obviously, I don't really recommend starting at 40 FPS and going to 120. That's pretty extreme. All right, so here in Remnant 2, unfortunately, I can't compare anything here, but we're going from 40 FPS on the right side up to 120, and then on the left side is a native 120 FPS, as it should look if every single frame was rendered properly. And you can see that even slowed down 25%, it looks surprisingly not that bad. Every now and then you'll see like this wave of like I don't even know what you call it, like the frame generation just being weird and wonky. Every now and then you'll just see that wave, like see the backpack right there, especially when there's like shadows and stuff going over it. Seems like it happens more, but it's surprisingly not terrible, which kind of blows me away, going from 40 FPS to 120. And if we compare it to NVIDIA's DLSS, you would think NVIDIA's going from what, 40 FPS up to 80 FPS here. It's actually not going to 120. This is only 80 FPS on the video side, so it might look a little bit more choppy than the lossless frame generation one because it's going to 120. So you can see this bottle here looks completely messed up on NVIDIA's frame generation. What the hell is happening there? I don't even know, man. That looks so freaking weird to me. You can see that the lossless frame generation, there's a lot of mushing going on behind the grates, like garbling, whereas NVIDIA's DLSS does definitely look better. But I still think even in motion, it doesn't look that bad when you're playing the game, because at least it looks smooth. Anytime there's a lot of detail stacked on top of each other, a lot of things occluding each other, that's when the lossless frame generation is going to struggle the most. So you see at these grates here, again, there's a lot of mushing going on, but surprisingly it doesn't look that terrible. Tiles there are getting like a little choppy and everything, whereas the DLSS frame generation definitely holds better there. But again, I just don't think it's that bad. How little this software has to work with, it does a surprisingly such a good job bringing it all the way up to 120 freaking FPS. It blows me away. It really does. Yeah, I think it's 40 FPS on the left side. And then in the middle, it is FSR 3 in Last of Us Part 1 here, so not DLSS anymore. You can just see like how much better lossless frame generation looks in this comparison here compared to FSR 3. It is like night and day. It looks so much smoother. It's crazy. Now it does have that thing, like it looks a little mushy around the things that are moving, but I would take that any day over what the heck is FSR 3 doing here? You know what I mean? What is it cooking? The lossless frame generation going up all the way up to 120 FPS does look a ton smoother than what 40 FPS natively would be. I mean, I hope to God that you're not playing at 40 FPS. Hopefully you can at least get 60. But man, it is surprisingly really good. And you might think that, oh, you really wouldn't want to play at that because of the latency that'd be in the game. Is like 40 FPS. It's already not that responsive with how you move things and everything. But surprisingly, this is like magic. It's crazy because the frame generation happening on the right side, going all the way up to 120 FPS, doesn't actually make the game that much less responsive. And I don't know how my boy THS is doing this, but even with this frame generation on, the game does not feel noticeably less responsive. You can peep it for yourself. The reason latency of your game changes with frame generation on is because the generation needs to know the previous frame and the current frame that you're going to in order to generate the one that's in between. And that means that the newest frame is being held back from being shown to you, and therefore you're waiting on a frame, and that makes the game less responsive. Now though, with frame generation tech that is integrated into the games like DLSS and FSR 3, they are able to cheat a little bit. Because they can get access to motion vectors in the game to predict where those objects are going to be moving in the next frame, which basically means that these technologies for frame generation, they don't need to render the entire next frame in the game. These ones only reduce responsiveness of the game by about half a frame instead of a full frame, which can still be quite a bit, but it's much less than what it could be. Obviously, with techniques like lossless frame generation or AMD's AFMF, they clearly add latency. Like AMD's Fluid Motion Frames literally has a damn stat to tell you how much latency you're getting because of this frame generation. However, this THS guy has found some way to minimize the lag without being integrated into the game or even into the GPU graphics driver. And it's super freaking impressive. Basically, a way that I think he might be doing this is not actually holding the current frame that's being shown to you in the game, but instead actually using the previous frame, so more of the frames beforehand, to build some kind of like predictive history where the mouse movement is going to go in the game, where objects are going to go into the future. And then if you can build up that history in the game, you can combine that by leaning a little bit more heavily on the machine learning, and you can predict where the frame would be in between these two frames. I might just be talking out my ass here, but I don't exactly know how he's doing it. I don't know if he's stated this anywhere telling us how he's minimizing the latency, but I'm just trying to find an explanation of how it could be so good. Given, especially with what he has to work with. Usually, like me personally, I can feel the latency that's added by frame generation, even with DLSS or FSR. But with this, bruh, it's nuts. But how does it work on your graphics card? I bet you're wondering, because it does require AI processing and decoding and all that stuff. And usually you're pretty much out of luck with the AI processing if you don't have an NVIDIA graphics card. But no, I am proud to say that this lossless frame generation technique works pretty much on anything. I tested on an RX 5700 XT. This is an AMD graphics card from 2018 that doesn't even support ray tracing, and it ran just fine. I tested on an AMD RX 7800 XT, as you obviously saw earlier in this video, and it ran great. On a completely budget $200 GPU, the RX 6600 was running great too. It's like I could run 1440p on this budget card. on an Intel Arc A770. It ran great, and obviously it ran great on NVIDIA's RTX 40 series graphics cards. And I was going to test this on my GTX 1070, so I think the old guy might be broken or something like that, because I could not get this 1070 to run for the life of me once I put it in a game. I was giving it CPR, I was reinstalling drivers into the night, checking for overheating, but no dice. My GTX 1070, I could not get it to run games. So if you try this on a GTX 10 series graphics card or something like that, let me know in the comments if you can figure that out. Although this whole testing section of the video does come with that major star symbol over here. It did work on all of these graphics cards, but whether or not you'd actually want to use it on them can change things significantly. And that is because of the performance hit that it can cause. So for example, the RX 5700 XT is an older graphics card, and I don't think it actually has the architecture to run this frame generation technique in an effective way, because it takes a huge performance hit. By turning it on, we lose almost 20 frames, which is wild when you're going from 70 to 50. That is a huge percentage. I don't really know the math in my head, but it's a huge percentage. The 5700 XT, I will say, does seem to be one of the more extreme cases, but it's definitely not the only one, because this phenomenon is pretty normal, it seems like, with the other graphics cards like the A770 and the RX 6600. I bet you're like, oh, we can just generate more frames, so it doesn't really matter, you freaking idiot. Which can be true, like, in a way. It makes the game look smoother, but it's not amazing, because a consistent locked frame rate is extremely important when using lossless frame generation. And in fact, it is actually important for all types of frame generation to function properly, but that's probably a bigger topic for another video. In particular with lossless frame generation, the way that it is able to generate frames is with a steady stream of frames, so it can insert the generated ones at the correct time and receive the correct image data that it needs to make a frame look right as well. If frames are coming in at different times, it's gonna look like all out of place. It's gonna be paced improperly, it doesn't look smooth, and they'll probably look garbled and crappy. So frames being consistent is really important. So basically how you want to do this is cap your frame rate at some multiple of your refresh rate of your monitor that you can actually maintain. And maintaining that frame rate is the hard part. When I was testing the 5700 XT, I was able to achieve 70 FPS before capping the frame rate, which should be enough to cap it at 60 FPS and be completely locked. But because the frame generation performance hit was so freaking large, it set me way below the 60 FPS cap, and that meant that I could not maintain it, which leads to like an image that God would not even forgive. It looked awful, not a way that anyone would want to play a game. There is some obvious workarounds. I mean, the big thing would just be to get a faster graphics card, wouldn't we all? Number one, if you want to try to work around this issue, would be to cap the frame rate for your game at a lower frame rate targets. So like 45 or 50 FPS in this case might help. But again, those frames are going to be less responsive, and they're probably going to look worse because there's more of a gap in between the generated frames to work with, and it has to do a lot more heavy lifting to make that look good. And number two, there is a second option here, would be to actually put the frame generation into performance mode. This mode reduced the frame generation processing on the 5700 XT by about half. So we went from losing about 20 frames to losing about 10. While it noticeably, but not significantly, degraded the quality of the experience, like the new generated frames looked a little bit worse. I didn't do like really in-depth testing to compare that kind of stuff. At least in the case of the 5700 XT, it is extremely debatable if you'd even want to use this frame generation when you could already be getting decent FPS before. I mean, 70 FPS is pretty freaking respectable. And then when you turn it on, you're actually degrading the image quality and responsiveness of the game just to get it functioning on the 5700 XT. And this dilemma is pretty prevalent on mostly lower end GPUs that are skirting the edge of like 60 FPS in games that you want to play. Because if you can't cap at 60 FPS, then you got to drop it down. You got to work with different things to get the frame generation working. It's definitely worth considering, But this is something to keep in mind, be a little wary of, that you might need to do some tinkering to get it to work on your specific card. The last thing about the performance is this, which actually bummed me out so much. This doesn't work on my Steam Deck. It's just so disappointing, because if I could use lossless scaling on a portable device like this, just to get more frame rate in our games without making a bunch of other processing and all that stuff, that would be so freaking nice. I don't know what was more disappointing, was trying all the different versions of Proton to get it working on my Steam Deck, all different versions of Wine, or what would be more disappointing is NVIDIA yapping about AI and releasing the same GPU every generation. I don't know what bums me out more. Speaking of that too, like this whole lossless frame generation thing is probably the biggest upgrade that we've seen for our graphics card FPS performance since we basically keep getting the same GPUs over and over again. Like the RTX 4060 is basically the same as a 3060, just a little bit faster with less VRAM. The RX 7600 is basically a 6650 XT at the same price. A 7800 XT is just a 6800 XT. Basically is like, yeah, the hardware, it's been pretty lame, but the software stuff with lossless frame generation, it's pretty freaking dope. And you know, $7 is $7. You know what I'm saying, boys? And let me know if you do try it. Just keep in mind the whole FPS caps things. That's basically it. That's the only tricky part about this, which is what I love so much, because you don't have to mod and get into the weeds with this stuff. You just got to program and you just click a button and it just kind of freaking works. The only weird thing though is this is on Steam, which isn't really a bad thing because it's a secure way to purchase it and everything. It's a trustworthy distributor, as far as we can tell. Sometimes there's scams. Because it is on Steam, you can only use this on one computer at a time if you're on the same account on both computers. I don't know if you're ever going to run into this situation, but it's definitely an odd quirk that I have. What's weird is you can actually stream the lossless scaling thing because it's a game on Steam. Also, check out Ugreen's new charger in the description. Like I would be holding it here to show you guys that I have the charger in my hand, but my cousin actually stole the charger and drove off with it because I guess it's just that damn good that they could not resist. Yeah, check out the charger. It's in the description, links, all that stuff. That's been it for me. Y'all have a good one, and peace.